our teacher. Or maybe not, depending on who's watching. What? Okay. First things first, please, let's put our names on these things. I've been grading and running into a lot of no names, and I'm sick of it. I'll be honest, I'm sick of it. Just write your name. Then it's not an issue. Woo! Excuse me, I've been talking all day, so my throat is a little worn out by now. Okay, before I get into it, let me just start by saying, last unit, our Unit 7, we learned all about exponents. We learned about how to multiply, add, blah, 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 blah. This unit, we are taking what we know about exponents and learning a new way to talk about them and describe them, and this thing, or these things called polynomials. These are kind of like strings of exponents of like what we've been working with. A monomial. So so I guess we can get right into this. A monomial, this is going to be really awkward. It's going to be blank space. I'm going to run. My notes are just on a table right over there. So don't leave. Don't leave. I'm still here. I grabbed them. They're in my possession. Don't you worry. Don't you worry. Here I am. Okay. Monomial. Maybe you're brilliant English learners or knowers, and you know this mono is a prefix meaning one. A monomial means one term. Now, maybe you're confused what a term is. Here are some examples of a term. A term is one group of numbers and variables. So here 8x squared would be an example of a monomial. Maybe negative 10 would be an example of a monomial. X to the fifth would be an example of a monomial. And maybe I'll even elevate that to say x to the fifth over 6. Each of these things is one group, one grouping of numbers and variables. And when I say group, I mean grouped together by multiplication or division. So fractions or just next to each other. So that's really important. The degree is this. The degree is the size of the variable's exponent. What that means is, hey, if we have a monomial like 2x to the fourth, if I asked you what is the degree of this monomial, you would say, oh, well, the exponent is 4. So all you have to do, I wonder if this would be a good color. Sure. All you do is you just tell me what the number of the exponent is. A polynomial, this is where things get fun. A polynomial is when we have more than one term. It's really 2 or more, and even later today in this lesson you'll hear that it's actually 4 or more is how we describe it in math, but it's still nice to know more than one. So examples. It's something like we would take a group. Wow, what is that? It's not Wednesday. we take a monomial, but then we like add or subtract another monomial. So we could take that 8x squared, we could add it to 10, and then we could subtract what? X. Here, this is an example of a polynomial, and in fact, we actually see 1, 2, 3. Here we would say there's 3 terms to this polynomial because there's 3 different groups of numbers. The degree of a polynomial is the number of the biggest variable's exponent. So, for example, we might see something like x squared plus 3x to the 5th. The degree here is, well, what's the biggest exponent we see? The biggest exponent we see is 5. Simple as that. The degree is just that number of the biggest. Ooh, and let me move my cursor off. Standard form, all that means is we order our terms biggest exponent to smallest. That means we would need to see like x third plus 4x squared minus 5x plus 17. All of the exponents here, we start with the biggest number and then we keep going down. The leading coefficient is the number attached to the highest degree. Variable. For example, if we had 4x to the 5th plus 6x squared, well, the highest degree is this 5th power, so the leading coefficient is just that number 4. Okay, I've been talking a lot. This lesson is just a lot of new vocabulary on how we describe things. When we look at a monomial, a polynomial, when we look at these strings, we give them 2 names. We give them its degree name and its term name. So, depending on what the degree is, we could call it a constant if there's no degree. If it's 1 degree, we would call it, come on, work for me, linear. 2, we call them quadratic. Wow, it is not wanting to work. 3, we call it cubic. 4 is quartic. 5 is quintic. And then 6 or more, we say this thing. We say nth degree. That will show up. Yes, that does show up in the example, in one of the examples. So I'll talk to you about that one a bit more. For our terms, we have monomial, binomial, trinomial, and then 4 or more, we call it a polynomial. The classic question is, how many wheels does your bike have? Does it have one monomial? Does it have two? Is it a bicycle, that prefix meaning two? Is it a tricycle? Are there 3 wheels? So on and so forth. Let me give you, no, we're just going to go to the examples. Haha, changed my mind. Okay, sun is in my eyes. That means we're feeling good. The sun is about to set. Standard form. Here we are ordering these terms, 1, 2, 3 terms, by the size of the exponents. So we start with the biggest. Here, the biggest exponent I see is that x to the 6th power. So I start by writing that. The next biggest I see is x to the 3rd power. So I write that next. So finally, I'll write that 6x squared last. Now that we've done that, the leading coefficient and degree become really nice and easy. Well, this is our biggest degree. So our leading coefficient is the number paired with the biggest degree, 15. And the degree of the polynomial just asks for that number. Now, for the classification, this is where we're going to use this terms list. When we look at the degree, we just found the degree is 6, telling us we call it this nth degree. Instead of writing nth degree, we substitute out that n and we just write the 6th degree. So if it was a 10th degree, we would write 10th degree. The question is, how many, let me try to erase these. How many terms are in example 1? Well, let's count. Here's 1 group, 2 group, 3 groups. There are 3 terms, which tells me when I have 3 terms, I'm talking about a trinomial. So our classification for this is a 6th degree trinomial. Same thing, same idea, example 2. Ooh, I'm getting hungry. The biggest exponent I see is this 3. Make sure you keep that -7. That negative sign is really important to keep. Next, we will go with 3x squared, followed by 12x plus 5. 12x being the next biggest, and 5. This 12x, let me actually say this. Remembering back from our lesson on exponents, we can think of that 12x having that 1 exponent. That might help you if you're getting mixed up with the order. The leading coefficient, well, that's just whatever comes first, so -7. The degree is the number of the exponent. Now, time for our classification. When our degree is 3, we call it a cubic. So that's our degree name. Our term name, well, how many terms are there? It looks like there's 1, 2, 3, and 4. Well, if there's 4 or more, we just call it a polynomial. Oh, and you can't see that. 2 more examples, then we're done. Okay, same thing, starting with the biggest, then the next biggest, then the next biggest. Leading coefficient is that number, -2. degree of polynomial is 4. We're going to want to start memorizing those lists of classifications. That's going to be really important for you to just rattle off and know. So here, remember what it is? It's okay if you look at your notes today. This is going to be a quartic. It's like quarter. There's 4 quarters in a dollar. Quartic. And there's 3 terms. So we have a trinomial. Wait. Oh, that's what happened there. My notes killed off a variable on accident, so my example looked a bit different. Here, let's order them up. Hopefully this is getting easier as you see me do it, or you're working through with me. Here the leading coefficient is 3. The degree on that is 2. A second degree is a quadratic. How many terms does it have? It has 1, 2, 3. So a quadratic trinomial once again. Oh, and you can't see that. Let me zoom out. Okay. There you go. Bippity boppity boom. The practice is yours to work on. I hope you have fun with this one. It's pretty fun. It's nice. You like this. I know you do. Okay, bye.